Hey everyone, today we have a Pioneer audio receiver amplifier model VSX-819H, and looks much like most receivers on the market, and this one doesn't turn on. We have a soft on off switch here. There is no light in the middle. Pushing that achieves nothing. What that means is there's microprocessor control on the power supply there, and as it's not a big physical clunky on off main switch, so seems to be a little brain dead. Let's dive on in. So here we have our mains transformer, and our mains input circuitry is actually underneath the speaker output board. So we've got the relays there for the speaker isolation, and all of the connectors on the back. So I'm going to take that out so we can get underneath and make it a bit safer to poke around instead of trying to reach underneath while it's plugged in. So here we have the black wire coming through to the first white connector there with the brown and blue wires. That's our mains input. So let's double check that we have 230 volts there. And we do. Now, hiding down under here, there's our fuse, mains input fuse. So that's always going to be on the phase side, so one probe in neutral, our blue wire, and we'll check we've got 240 on one side of the fuse, 240 on the other side of the fuse. There we go. Well, it's actually 237 at the moment, so that's alright. So let's have a look at, we can see that the black and white wire there goes into the transformer, so that's going to be our primary to the transformer. It looks like we've got a secondary tap coming off here. There's also another secondary tap on the other side of the transformer further up there. It's just this bunch of wires coming down here. So let us see, do we have power going to the primary side? I'm checking there. Okay, it appears we don't. So there's no voltage getting to the transformer. So what causes that? If I had to guess, I would say that this transformer here is our just a low voltage feed for the soft start on-off circuit. And this relay here, just because of where it sits next to the fuse and everything, this is probably the relay that gets activated to power up the main transformer. So what we need to do is probably pull all of this out, unfortunately. But before we get too carried away, so on the top here we can see 4 diodes. So that's going to be our bridge rectifier for this this input here for the secondary side of this low voltage supply. So we can even see the word secondary there, and this is going to be a capacitor for it. So somewhere, I'm guessing one of these, probably one of these links, these wire links, are probably going to be our going to have our secondary voltage on it. So I'm just going to poke at those and see what it says. We'll use the screw head, the top right there, for our ground, and see what's going on here. There we go. I've got 3.2 volts. Now I don't have a service manual, so I don't know what it should be. 3.2. Okay, so we know that we have something. To see if there's anything printed on the board that would suggest what voltage should be. Now the capacitor there is a 16 volt cap. and then we've got a 50 volt, the little one's a 50 volt, and what else have we got? It looks like the same, it's a 50 volt as well, so maybe it's supposed to be a bit higher than 3 volts. I'm going to say it's probably supposed to be more than 3 volts. It's not a lot to work with, because I think they'd use that same voltage to energize the relay as well. So I'd be thinking maybe it should be a bit more than, maybe closer to 12. I'm just going to check the diodes there. The one on the second one from the left, it might be my imagination, but it looks like it could be a bit darker than the other ones, so maybe something's gotten a little bit toasty. Now, I have unplugged the unit and made sure the caps are discharged, so we know we've got no stray voltages floating around that might give us a false reading. That one's okay. Second one in. No, that's actually okay. Half a volt drop there, there, and there. Alright, I'm interested to know what our resistance to ground on that rail might be. So one probe on the screw, looking at our resistance, one probe on there. 480 ohms. Not too sure what it's feeding, but thought it might have been a bit. Thought it might be a bit more than that. Do I pull it all out, or do I look for a schematic? You got like half a dozen screws holding it in. At this point, though, it'd be good to know what it should be. I'm just going to plug it in again. I've just found a spot on the board with a voltage. We'll see if it's got any there. On the back of the front panel, we've got the flex going up to the front from the main board, and it has a whole lot of stuff printed on there as to what pin does what. And what I'm going to do is, not far down from the top, it's marked MC 3.3 volts, so I'm picking microcontroller. So I'm just going to see then, has that got 3.3? And yes it does, so alright. Okay. So that's interesting. I wonder if the on-off button is a bit dicky. Here's the standby key on the back of the front panel. It has its own separate board with, I think it's the volume button control, maybe. So let's have a look at that one, see if there is a voltage there. And I've got 3.3. So, does the switch pull it to ground? Oh, can I reach around there? I need to get a better angle. 5 hands, there we go. And I push the button. Okay, so when I push the button, it does pull the signal to ground. So, in theory, the microcontroller should be able to see that, and therefore it should know and activate the relay. So why doesn't it reactivate the relay? Aha! Back to the other side, and looking at the other numbers there, we've got one marked standby relay. So that one there, and get a probe on it without shorting it to all the other ones beside it. That there should be standby relay. And at the moment it's got 0 volts, and it's still got 0 volts. Okay, let's try the one behind it in case I'm wrong on what pin it should be. Okay, nothing there. Nothing there. Nothing there. Nope, so that one is definitely standby relay, and there is definitely no signal coming off it at all. So that tells me obviously it's all controlled by the micro on the front panel. So this could be a front panel fault then, and it would have been a pointless pulling out the whole main board at the bottom there, wouldn't it? Okay, let's trace this back a bit. See what we can do. Sorry, I can't really get you a closer image than that. The lens on this camera is not the greatest for doing zoom, but if I go any closer, I'm sure it's going to be real blurry for you. So we've got standby relay control. It comes up here. There's a couple of traces, but you can kind of just sort of make them out. It runs along to here, which is going to be a jumper wire. It jumps over to here, and it comes down into this transistor. So let's see what's going on the other pins of this transistor. We know that that pin's got nothing on it. We know, what else have we got going on here? That pin's got nothing on it, but that is possibly pulling to ground by the look of it. And then the other side has got 3.2 volts, which doesn't change with the button push. Okay. Why not? I just should have done the obvious first, shouldn't I? Follow the standby key pin all the way across to here, and it goes straight out the flex. So that's just a display driver. That's nothing. We're not concerned with the front panel anymore. It is converted into one of these, which is possibly that one marked key 1. Here we go. So key 1 drops to 0. Here we are. So key 1 goes down to the main board. Key 1 down on the flex there. Yep, that pulls to 0, so we know that our flex is intact. That's a good sign. So I'm cheating a little bit. I've lifted the whole back panel up with everything attached. I haven't taken the board off separately. All of the subboards are still attached. And we'll have a quick eyeball under there and see if there's anything obvious. Let's start in the power supply again. So there's a lot going on here where the little standby power supply functions. There's our diodes, a row of diodes there. They go into a bunch more diodes, little surface mount diodes, some transistors, and a couple of larger packages there. So there's quite possibly a couple of rails that come off this supply. So here we can see these two pins are our coil side for the relay, so this is where we control the relay. The top pin is our power or voltage feed into the coil. It is fed via a resistor, just to limit the switching current, I'd imagine. The end of that resistor comes off and down to here, so it goes from the relay, feeds the relay, and it also feeds up to here, which is a diode, and then above that is a resistor, and then up to here into a connector that says plus 12 volt. I knew it. I knew we'd need to have more than 3 coming off the secondary of that to run anything. I haven't seen a 3-volt relay yet. Oh, they might exist, but I've never seen one. Not in a product like this, at least. So we'll go to our relay. We've got 10 volts there, and of course 10 volts there because it's not being pulled to ground by our control. And that control signal comes from, it says a resistor to ground across that, so it holds that in an off state. That runs all the way down here and back up to this resistor, which then runs all the way up to the processor. So I have traced it through, and I will stick a probe on the processor higher up on the board. Now I've traced it through to this pin here, which also tees off and goes to the front panel. Now this is the it's on an angle. If we call it the whole bottom row, very right hand end pin. If I push the button, and I'm getting nothing. 25k ohms to ground is not a problem. It should be able to provide a voltage. Trace through from the front to here, which this goes up to the processor, and just to make sure the signal is getting into the processor, when I push the power button I see it drop to 0, so I know the processor is being told to turn on, and there is no reason why we should not be getting a signal out of the processor to control the relay. So I'm thinking the processor is dead, and I think this is an integrated unit. This is a microcontroller, which means there's no EEPROM, which means I can't just replace it. It's what they call a mask ROM. It's or it's one-time programmable. I don't know. It's hard coded. Yeah. So the only way to fix this would be to get one off another board. It looks like. I found the service manual, and it doesn't really help me much. It's basically confirmed everything that we've worked out. Yes, I did also check the reset line to make sure that the CPU wasn't being held in a reset state, which would also stop it functioning. I found a protection line that I'm not entirely sure what it's monitoring. I think it's power rails, but that appears to be okay as well. But anyway, the processor used in this is a what's the number on it? M-3030 RF-EPFP. And what I've just found is the HDMI card has the same processor, and not only that, there is an EEPROM down on the main board. So these are not programmed. These actually load in their code at startup. So hey, why don't we just take this chip and put it down there and see if it works, and if it does, we can order another one to make the HDMI board work again. It's worth a shot. Well, the best info I can find is that this is a Renesas chip, and there's really not a lot online that I can find other than that seems to be what it is, probably made just for Pioneer, and because there's other numbers out there like M-3060 blah blah blah. The code F, one of the first F in there, stands for flash memory, so it will be pre-programmed, and that means we can't swap the chip over. It'll have a different code in it. So I don't know if we'd be able to read out the code and reprogram it, for example. Probably not. No, not with my chip reader, so that's it, I'm afraid. This one is not repairable without getting that chip from Pioneer, pre-programmed or stolen off another board, which you just can't order one and trust that it is off the right board. So it's unfortunate, but thanks for watching anyway, and hope you're all doing well. We'll see you next time.